on Illinois farmers and farmland are part of the climate solution. And this webinar is being hosted as part of the Soil Health Week, which is an amazing lineup of lots of different events and webinars and field days and discussions around soil health, climate resiliency, water quality, opportunities for more resilient food systems, et cetera. And that it is organized and wrangled by our good friends at the Illinois Stewardship Alliance. And I think I saw Liz Stelk, I think I saw her name pop up here, and I think maybe a few other folks from Illinois Stewardship Alliance are on. So gratitude to them for hosting this, putting this all together, and including this webinar in the discussion. Bonnie, if you can go to the next slide, I just want to kind of do a little bit about us. American Farmland Trust is a national nonprofit organization that really was started in 1980 as a farmland protection entity, and protecting farm and ranch land is still very much part of our mission, but we also do focus on protecting or promoting sound farming practices and policies and practices and programs that keep farmers on the land. I'm Jean Brokish. I already introduced myself twice, so I'll skip that, but I'm also joined today by Bonnie McGill. She's our senior climate and soil health scientist, and Bonnie is based in Pittsburgh, is that right? But a Midwest native originally. And then we also have a support crew of other folks from the Midwest team with AFT. We have Catherine Pagura, Helen Van Beck, and Rachel Lechuga. They're helping behind the scenes, and you'll also meet them in the breakout rooms. So I think we are interested in learning a little bit about you. I did encourage people to put name and location in the chat, but I think, Bonnie, if you hit next, it'll prompt for a little poll. I think we have a poll designed. We'd love for you to just take a minute to respond to that and help us understand what your current knowledge is in terms of climate benefits for conservation practices. All right, looks like most people have answered that. I think we can go ahead and share the results. I'm not sure. Are you all seeing the results there? Okay, yeah. So it looks like about a third of you are very knowledgeable, and over half are somewhat knowledgeable. So looking forward to hearing from you and some good discussion as we get into the breakout rooms. And then the not very knowledgeable, well, we're hoping that we can share some information with you and build your confidence and allow you to help communicate to others about the benefits of these practices. So we'll go ahead and minimize that. And I think, Bonnie, the next slide, I think we just turn it over to you and you can start with your presentation.
Okay, great. Thanks everybody for coming. It's great to see you. Like Jean said, I've spent a good amount of time in the Midwest. I went to Michigan State for grad school. I lived in Iowa and Kansas, and I'm excited to be doing work that's relevant to you all today. So the agenda for today is I'm going to present some information about soil health in general and soil health practices with carbon benefits. And then we'll talk about this CARPE tool that the talk is really focused on and how it estimates carbon benefits. Then we'll move into one of our 2 breakout sessions where we'll have time to share experiences and ask questions. Then we'll spend time looking at how CARPE tool estimates for those climate carbon benefits for soil health practices in Illinois. We'll have our second breakout group. Then we'll come back together and we will run a CARPE scenario together. So I'll screen share, we'll go into the tool online. You guys can shout out cover crops, these different things, and we'll build it together so you can see how it works and maybe feel comfortable running it yourself for your own area. And we'll have time at the end for a Q&A. So I know we have a varying degree of comfort and familiarity with soil health, so we'll just go over some of these basics together. It'll be a review for some and maybe some new information for others. So soils are a living ecosystem. Their building blocks of soil health are the soil microbes and the aggregates that they build. So here I'm showing you a cartoon of an aggregate. And those aggregates are the building blocks for all the cool functions that we rely on from soils. And we can say that those aggregates are sort of like houses, because, let me get my buttons all straight here. Because we build houses, we take care of the structure, and we really use them for their in-between spaces, just like how soil pores are essential for regulating air, water, and temperature. Aggregates are made up of these little pieces of minerals, organic matter, living organisms, and are held together by special biological glues, which we'll talk about in a second. So really, soil structure and function are really driven by the biology beneath our feet. So let's take a closer look at how soil aggregates are formed with all this biology. Here we're looking at a scanning electron micrograph image. The stripe here at the bottom is 400 micrometers, so that's about 2/5 of a millimeter. So we're really zoomed in there. And you're seeing a network of hyphal fungi that are holding soil particles together with little bits of crop residues. And this is all part of soil aggregate formation. And like I mentioned, there are these microbial glues that bind all of these particles together into stable aggregates. And those glues are produced by both bacteria in the soil and fungi. And these bacteria and fungi need to be cared for, like below ground livestock. We can't starve them for 8 months of the year or leave them out in the rain. So that leads us to talking about the soil health principles. And these are the 4 key principles for high functioning soils. So these are the principles behind the practices that build and protect the soil's physical and biological structure, which leads to these great functions we rely on, like food production, water cycling, climate regulation, and lots more other great stuff. So first off, the first 2 principles focus on feeding the soil. So we need to maximize the living roots and throughout the year. And roots actually exude carbon into the soil, and they're feeding those beneficial microbes and fungi. And what that does is it takes solar energy that plants turn into carbon through that cool thing they do called photosynthesis, and it feeds that carbon, that below ground food web, and their energy. We want to maximize diversity, so that's including your cover crops as a form of diversity in your crop rotation, diversifying your crop rotation of your cash crops, and even integrating livestock. That helps bring the waste nutrients from livestock back onto the land, so it's more of a cycle of nutrients. Once we're building that structure, we also need to protect the structures, much like a house. So like an earthquake can destroy a house, plowing will undo the hard work of microbes to build that structure in the soils. Disturbances can also be chemical. We want to maximize cover, so that helps reduce disturbance, and it helps maintain soil organic matter and aggregates and reduce erosion and runoff risk. Side question, my dog is being loud and chewing on a bone right now. Can you all hear it?
We can hear it a little bit, but
okay.
Yeah.
I'll take that bone away. She's right here. Let me do that for a second.
We're a pet-friendly and family-friendly environment, right?
Sorry about that. I was like, can everyone else hear that too? All right. So yeah, we're protecting the soil organic matter and the aggregates, but what's in it for the farmer, right? We're doing all this stuff. So let's go back to thinking about soil function and how our heaviest rain events are getting heavier, but also in the Midwest, we're having hotter, drier periods in the summertime. So how can the soils and all this work we're doing help us out? So this is where that soil structure meets function again. So a key function for adapting to excess water, but also drought, is allowing water to infiltrate and pass through the soil. So on the left, we have a soil with pore structure. It's one that's been tilled, eroded, overgrazed, and compacted. That pore structure means the soil aggregates have broken down and they've lost those critical pores. And these soils act more like a roof. The rain hits the soil surface, they can't infiltrate, and the water runs off and carries some soil with it. These soils are also harder for plant roots to penetrate. And it's hard to get your equipment out onto these soils after a heavy rain because that water is just sitting there. On the other hand, if you've been using soil practices, feeding those microbes, protecting the structures that they build, also allowing earthworms, roots to penetrate in there and make nice channels, you'll have soils with good structure and function. So here, the rainwater more easily infiltrates into the soil profile. You've got less ponding, less runoff and erosion, and it's easier to get out on these fields after a rain. So they install field tile. Exactly, yeah. So you might actually not have a drainage problem, but you might have an infiltration problem, but try to solve it with tile drainage. Great point. So it's easier to get out onto these fields after a rain, but also more water has actually reached into the soil profile. If you're to take a shovel out there after a rain event, you'll see that there's actually water in the soil deeper below. Whereas in this situation, you would dig down, you'd see that this soil can be bone dry after a rain. So these soils act more like a sponge. And so that helps you later in the year. Also, your plants are able to access water. The pore structure, the P-O-R-E, the pores in the soil are able to hold water for the roots to access that later in the year. So this is nice for the farm and the crop, and it helps reduce flood risk downstream because the landscape is acting more like a sponge than a roof. So it's really helping everybody. Many soil health practices are helping farmers both adapt to and mitigate climate change. We're going to be mainly talking about mitigation for the rest of the talk, but I wanted to kind of emphasize how these practices do both things. They can help reduce inputs like fertilizer and pesticides, improve infiltration, like we just said, as well as improve that soil water holding capacity, increase soil carbon storage, so getting into that climate mitigation, and reducing greenhouse gas emissions. And these things are a whole system of practices that work together over time. And it's not easy. It takes effort to learn to work with the ecosystem and the climate that you have and the changing climate. But don't take my word for it. AFT has a whole team of economists who are doing soil health economic case studies with soil health successful farmers. They're doing partial budget analyses with farmers who've been using these practices and documenting both the increases in net income due to adopting more practices, as well as the decreases, and looking at the net impact. So this is one case study. I don't have time to walk through the whole thing, but we have two from Illinois, and this is one of them, Thorndike Farms, and they found a net increase in their income of $34 per acre. So from reducing tillage, changing up, doing more nutrient management practices. And we have the link there in the chat. We'll also share that again at the end for you to look at those case studies, use them yourself. There's also a methodology if you'd like to do more case studies yourself with farmers in your area. But let's talk more specifically about those practices. So these are some of the cropland and grazing land practices you might be familiar with. And these are some of the ones that NRCS has identified as having climate mitigation benefits. They do things like build soil carbon, reduce greenhouse gas emissions, reduce carbon dioxide losses from the soil. And when I say greenhouse gases, I'm also including nitrous oxide emissions there from nitrogen fertilizer. So that's all great. But this should be the point in the conversation where you interrupt me and you say, that's nice that the practices do that, but how much carbon, Bonnie, right? That's the big question everyone really wants to know these days. So enter the CARPE tool. So that stands for the Carbon Reduction Potential Evaluation Tool. So you can imagine why we shortened it to CARPE. And CARPE means seize, right? And so we say seize the carbon. And this is a screenshot of what the tool looks like that we'll look at later when we do our live demonstration. It's a collaborative tool developed by scientists at AFT and USDA ARS. It's free, it's online, interactive tool, and it works for the contiguous 48 states of the US. And it allows you to quickly visualize and quantify CO2 emission reductions from implementing a suite of NRCS soil health practices. But I want to take a moment here to remind us that carbon is not the only horse in this race for solving climate change and how agriculture can help solve climate change. I mentioned there's also nitrous oxide emissions from croplands, mainly from synthetic nitrogen fertilizer. There's also methane from livestock. The state of the science allows us to make tools like this to make estimates for soil carbon. So that's why we're able to do this. But an area of research at AFT right now is to add to the CARPE tool a way of estimating N2O emission reductions as well, because that's really important for climate as well. So get off my little soapbox and let's go back to talking about carbon, which is also important. So how CARPE works is it really marries together two data sources. The first one is called Comet Planner. It's a tool, an online tool also. It's available from USDA, and it provides an easy to use web-based tool to evaluate potential carbon sequestration and greenhouse gas reductions from adopting NRCS conservation practices, right? And if you're curious, COMET stands for the Carbon Management Emission Tool. And so at its core are these things called emission reduction coefficients. And what those do is they give us an estimate of the metric tons of carbon dioxide equivalents per acre per year that are changed due to the practice. So it's not telling us what's happening as a baseline, but once you implement a practice, how is soil carbon changing? How are greenhouse gas emissions changing? And so what that looks like on your farm is you have a crop, you have your soil organic carbon, the crop is taking CO2 through photosynthesis, some of it's reaching the soil, staying in the soil, and then also CO2 is being decomposed and turned into, soil organic carbon is being decomposed and turned into carbon dioxide. And that gets ramped up with tillage especially. So let's say you implement a new practice such as reduced till or no till. What this emission reduction coefficient does is it says how much more carbon is reaching the soil and how much is that practice helping to lock that carbon in there and reduce CO2 losses. So as you can see, the units there are per acre, right? So then if we know the per acre, the acreage in a county or a state that a practice is happening, or in a future scenario, how much we would like that practice to happen due to say like a change in policy, then we can estimate these benefits at a larger scale. So then comes the second piece of CARPE, which is turning to the US Census of Agriculture. And the most recent census was in 2017. And the survey is actually, someone can correct me, it's out right now, or it might have, the due date might have passed. So feel free to put that in the chat. But this is an example of how it's really useful to have that data and to fill it out and send it in. So we take acres from the census information that tells us by county how much cropland there is, but also they tell us how many cover crop acres as well as no-till and reduced till, so that we can scale those up and say how much is this county helping, how much is this county's agriculture helping the climate, how much by the state. So that's what the CARPE tool helps us do. And what you can, the kind of things that you can do with it, if we look more closely, is you can map acres of cover crops in conservation tillage at the county and state level. So this is looking at percent of acres by county in Illinois from the 2017 census, percent that are using cover crops. And that kind of allows you, maybe if you're at the state level, to say, hey, what kinds of programs are happening in these areas with darker colors that maybe I can help share with other conservation districts or watershed programs to increase crop acreage that's using cover crops. And then you can take those acreages and estimate the CO2 reduction potential from those current adoption levels, as well as future scenarios. And then for practices that we don't know the current adoption that aren't captured in the survey, we can do future scenarios with those to make estimates for the CO2 benefits. So altogether, you can take that sort of raw input or output, sorry, that you can get from CARPE. And this is an example of an infographic, a 2-pager that we made at AFT summarizing results for Illinois, which we're going to dig into more in a few minutes. But what CARPE allowed us to do was to say, okay, the EPA tells us that agriculture in Illinois contributes about 17 million metric tons of CO2 equivalent emissions per year. That's about 9% of Illinois' net greenhouse gas emissions across all sectors. But if farmers successfully adopted the below systems of practices on 80% of farmland, which is a lot, but it gives us an idea of what the potential is for agriculture, Illinois could mitigate a total of 34 million metric tons of CO2 equivalents per year for up to 20 years. And the reason we say that for 20 years is because soils will eventually saturate. And so the building up of that soil carbon will slow down. So that's a little footnote there. But the big thing you can see there is that that's about twice as much as agriculture is emitting. So that if we look at the full greenhouse gas emissions for the state, agriculture could potentially offset about 14% of the emissions. And so if we look specifically at what practices those are, it's mainly these 4 practices in the graph. And we're going to share these results with you and this full report with you with a link at the end. But mainly wanted to, kind of give you a teaser before we get into the full details of what you can do with Carpe. So now we're going to pause.
Sorry. Oh, go ahead.
Yeah. Oh, did you want?
I was going to say there is a question from the chat from what variables do you measure? And Kevin put that up when you had the previous slide up here. So I think it was just maybe kind of as you were setting up Carpe or Kevin, I don't know if you have additional clarification for your question. You're welcome to come off mute and ask the question too.
Yeah, sure.
Well, you have a what is it? Your emission reduction coefficient. What factors do you measure to come up with that value? How do you come up with that value?
Great question. Yeah. So what Climate Planner does to come up with that value is it relies on a ecosystem process model, which takes into account the climate of a location. So it's like multi-county area specific. So it's looking at the soil type and the climate, and it's looking at what the general kind of common practices are in that region and what we know about how changing those practices will affect the soil carbon. So these coefficients, and that's a great point that I forgot to mention, are location and soil type and climate specific. Does that kind of help, Kevin?
For sure. Yeah. Thank you.
Sure. Yeah. Thanks for asking that. So yeah, we're going to go into our breakout conversations now because we know you all have a lot to share as well. So we're going to kick off the conversations talking about, sharing experiences you have with how soil health practices can help a farm adapt to weather extremes. Also, if you have ideas at this point about how you might use the economic case studies we mentioned or the Carpe tool, try not to get too set back by the technical details of the tool, because we're going to get to that in a few minutes, but just sort of like, how could you use these mitigation estimates from soil health practices? And also thinking about which audiences of yours would be drawn to this kind of information and which ones wouldn't. We're not saying this is like a silver bullet for everyone. So that's a good thing to talk about as well. So I think we're gonna be in those groups for 12 minutes. And so we'll come back at 10:38. Someone wants to check my math?
Conversation. I think, Bonnie, we want to just use a few minutes here, right? And kind of run through and see if there was any high level questions or knowledge gaps or anything like that. So maybe I can kick us off here and just do a real quick report out from the session I was in. Interesting, a lot of practitioners and people who are working with groups of farmers, and the question or the comment was like, how do we actually use this then to communicate about like Kendra from the Midwest Dairy, was like there was a lot of overlap between the areas where the cover crops were in use and where the dairy farms are. So is there a correlation there, something to explore? And then how else can this information be used to maybe support policies? Nathan with Farm Bureau was interested in can we advocate for some additional resources for farmers based on those environmental benefits? So some good conversation there.
Yeah, those are great questions. And so with the overlap between dairy acres and where there's cover crop, I think that's a great question. You know, we could look at the USDA has a cropscape tool that tells you what is grown in different areas. So we could look at that and where cover crops are, and maybe use like map out where manure management plans are to look at where there are dairies, to kind of look at that correlation. So that would be kind of interesting. You know, how are dairy farmers contributing to this? For the policy question, that's a great question, because that is sort of one of the impetus for CARPE at the state government level, is to sort of compete with other sectors that have a climate benefit, so that when a state is saying, okay, we want to have a climate action plan, we can, you know, should we invest in energy? Should we invest in transportation, building efficiency, you know, those kinds of things. And this tool is trying to say, hey, agriculture is helping too, invest in us. We're a solution right now. We're one of the few sectors that can take carbon out of the atmosphere, not just reduce our emissions into the atmosphere. And people's question is often, but how much, you know? And so this tool is trying to say, here's how much, you know, so we can compare apples to apples between the sectors, and also advocate for, if you make these investments in agriculture, here, you know, that's investing in your rural communities, rural economies, and those kinds of things as well. So it absolutely can be used to advocate for investments to help farmers adopt these practices. So it's a great question. Does this work for other states? Yeah. So it works for the contiguous 48 states. So when we look at it, we do the walkthrough together here later, I'll show you that those states are there too.
Helen, Rachel, or Leah, any, or Bonnie yourself, you also had a session. Any other high-level ideas that came out of your sessions?
I can share from our group. We had a few people who are landowners and working with their tenant farmers and thinking about, you know, how to support them and making some changes that would be, yeah, better for the land. And so we just talked a little bit about, like, what does that decision-making process look like? How could this tool be helpful? How could the economic case studies be helpful? And really just showing, you know, what some of the benefits are, both for kind of the landowner tenant farmer relationship, but then we also talked a little bit about, you know, what your neighbor's doing and how your neighbor's runoff might affect you. So yeah, just thinking about kind of that relationship dynamics and sharing some of these tools.
Awesome. Yeah. Non-operating landowners are like so important, and recognizing that sometimes, you know, farmers are willing to make these changes, but they don't want to rock the boat with you. So it's helpful, you know, if you come to the table and bring things up, and also thinking about ways to reward them for doing that. So maybe giving them like a longer term lease, because they're not going to see the benefits of soil health practices in 1 year, but you'll see it over the long term if you have people doing that. So that's one idea, is to help give them that security of a longer term lease. So should we move back into the presentation to stay on time here?
Yeah.
Okay, great. Sounds like we had some great conversation. Let me share my screen again. Okay, so now we're going to move into looking at some of the estimates from the CARPE tool for potential climate mitigation from soil health practices in Illinois. And this comes from, there's also a full-length report that I'm drawing from for this, that we're going to share the link to for you at the end, so you can get even more details there. So I mentioned that you can get maps. We already saw this one on the left. That's the % acres by county that are using cover crops. And here it is just in the number of acres. It can be a little confusing because larger counties with more acres will have more acres. So the percent can be useful, but overall, Illinois only has like 3% of its available cropland acres using cover crops. And then we can look at no-till. So we've got 29% of acres in Illinois using no-till, and here it is by percent of acres, and then just acres on the right. And this is the third set of maps I want to show you. The last set of maps is looking at reduced till. So we know that 42% of Illinois cropland acres are using reduced till. So here it is by percent. We've got some nice high percentages there, and then also by acres here on the right. And again, those number of acres comes from the ag survey, and we're just mapping it here using Carpe. And I mentioned, sorry, this should say 20 years here, but I mentioned earlier those emission reduction coefficients and how they're location, climate, soil specific. So if we average those for the state of Illinois, because each county has its own emission reduction coefficient by practice, so each practice has a coefficient. If we average those to get a look at how they work in Illinois altogether, so these are the different practices. You can see that a legume cover crop, that's going to be adding a lot of soil carbon. So let me explain a little further here. So we've got the 0 line running down here. Positive means we're adding soil carbon. Negative means we're either losing soil carbon or we have emissions of greenhouse gases. So brown is we're adding soil carbon. Green means where there's a change in N2O emissions. So the legume cover crop is adding a lot of carbon. Legumes fix nitrogen from the atmosphere, so you have some more nitrogen cycling happening, so you can have some more nitrous oxide emissions also that come with that. But the net effect, this dot here, is still very positive, as are all of these practices you can see here. So that kind of gives you an idea of kind of the difference in the strength in these practices for having a climate benefit in Illinois. And so these will change for different states because they have different soils and climates. We were interested in estimating kind of the full potential for emission reductions that can happen in Illinois to kind of say, hey, here's what we could shoot for, you know. So we used an 80% of available acres scenario. So imagining if 80% of available acres adopted the following 7 practices. The reason we didn't do 100% is because we know from sociology that the adoption of practices, you know, you kind of have your early adopters, and then you have this middle. Once something becomes normalized, you have a whole bunch of people who will come in, but you kind of have that tail of slow adopters, late adopters, laggards, and we just, you know, we probably won't get that 100% unless it becomes like a law or something. So we went with 80% in this scenario, and for 7 practices, with the exception that we added mulch to 80% of specialty crop acres, because there isn't enough mulch probably in Illinois to mulch 80% of cropland acres. And then with pasture land plantings, we did that on 20% of pasture land acres, because that's needs to be added to degraded pasture land. And so we kind of had to estimate what that is. We went with 20%. So the practices, so this is showing you all those practices together. Different practices are in different colors. No-till was the biggest. Doing a legume cover crop was the next biggest, and that also includes, from the COMET planner, the way they estimate that, they also include a minus 50% nitrogen fertilizer with that. But most of the carbon benefit is coming from the cover crop. Then strip cropping, so that's planting perennials and strips through your fields, and then conservation crop rotation is the next one. And within this tiny little sliver, if you can kind of see it there, that is pasture land planting, prescribed grazing, and adding mulch altogether. And so that's where that 34 million metric tons of CO2 equivalents per year. So this is kind of another way of looking at that bar graph you saw earlier on. And so if you recall also I said, so Illinois ag emissions are 17 million metric tons, and the total emissions are about 234. So agriculture could offset about 14% of Illinois' total emissions. And I want to point out that this is not the case for all states. Illinois agriculture, mainly because of its huge land base of agriculture, has an exceptional capacity to mitigate climate change. This is pretty cool what we can do in Illinois. And to help put that even further into perspective of like, what is 34 million metric tons? So that's the equivalent to avoiding over 180,000 rail cars worth of coal burned. And as someone who lives in coal country here in Western Pennsylvania, that's a big deal. It's also the equivalent to taking 9 coal-fired power plants offline for 1 year, which is pretty cool. We often don't talk about like comparing sector to sector, but you know, 1 molecule of CO2 is 1 molecule of CO2. So, and then the third and the last way I'm going to show this to you is that's the equivalent of emissions avoided by running over 9,200 wind turbines for a year. So like, wow. Okay, but also it's going to take a lot of work to get to that 80% scenario, but it can do a lot for the climate and for farmers. So if we zoom in specifically on cover crops and conservation tillage, that conservation tillage being both no-till and reduced till together, and I'm focusing in on those because they have a big climate impact, but also they're the two that we know their current adoption from the ag census. So currently, the tons of CO2 equivalents per year that they're sequestering based on the acres that they're used on, cover crops are currently sequestering less than 1 million metric tons per year. But with the acres that are available, remember that's just 3% of Illinois cropland acres. If 100% of those cropland acres were using cover crops, we could get to 12.3 million metric tons just with cover crops. And remember that Illinois ag emissions are about 17, so we can get pretty far just with doing more cover crops. And conservation tillage currently is sequestering about 6.7 million metric tons per year. But when we convert what is currently reduced till to no-till and what is currently intensive tillage to no-till, we can sequester another 10.1 million metric tons to get to a total of almost 17 million metric tons, which is almost equivalent with ag emissions just with that. And so together, what just cover crops and conservation tillage could do in Illinois is about 29 million metric tons of CO2e per year. And we're not yet talking about nutrient management, biochar, reducing methane emissions from livestock, all these other things. So, so that's pretty great. Yeah, and also I want to say that, you know, these two dark colored bars are about 24% of the total potential that we could have. So what I hope this shows is that everyone's work here to get no-till and cover crops on more acres in Illinois, which can be for lots of different reasons, is important climate work as well. So this is the 2-page brief we made, and I showed you this little corner of it in my slide. And so you can get it from this link, which we'll share in the chat. If it's easier, you can pull out your smartphone and use your smartphone's camera to scan that. And so this is a 2-page summary. We also have a full-length report at the same link for Illinois that goes deeper into detail of some of the stuff we mentioned today. And so with that, we are going to, and I'm not able to see the chat, so if there's anything I missed.
So there's 2 questions that came in, Bonnie. One was from Don and just asking whether CARPE has been shared with USDA to aid farmers in monitoring carbon sequestration levels and perhaps inform some carbon market services, et cetera.
Yeah, great question, Don. Thanks for that. And so this tool was made in collaboration with USDA ARS scientists. And so USDA is aware that we have this tool. What I would say at the farm level, because remember, this is at either the county or the state level. The farm level tool that I would turn to would be the Comet Farm, which is another USDA tool that's for a whole farm or whole ranch accounting of what's coming in and what's going out in terms of a greenhouse gas footprint. So I would use it, I would turn to that. And then in terms of carbon credit market services, that's a great question as well. And I think that again, the Comet Farm would be your best kind of place to get started getting that information. But Jean might be another person to talk to about like, how do you compare carbon credit market opportunities and things? Do you want to add something to that, Jean?
Yeah, well, I think how I've used it when I've communicated around carbon market opportunities is just to understand what the relative potential is for these different practices. So if you're a farmer, you know, you might be looking at somewhere between 0.5 and 1 credit per acre, which is really reflected in that ERC value, or the cumulative ERC value that Bonnie had shared in that chart. And so it's just helpful to kind of understand what realistic potentials are for you as a farmer if you're weighing entering into some sort of carbon market, because it could kind of help you get a realistic expectation of what the financial incentive would be back for you.
Yeah, that's a great response.
Yeah. There's also a question from Kevin. I love this. Yeah, what is the best cover crop? Which cover crops are best? So from a climate perspective, I don't know, Bonnie, just off the top, is there a difference between legume and non-legume cover crop in terms of climate potential?
Yeah, so because the legumes are pulling in, fixing their own nitrogen, they're able to be more productive and bringing in more carbon. So as you can see, that legume had a bigger emission reduction coefficient than the non-legume. The legumes are more expensive seeds, and I feel like that question is almost a trick question. And I love what Helen added there below, the Midwest Cover Crop Council. Those are great folks, and they have a decision support tool. So I said it's a trick question because it really depends on you and your situation and what your goals are. In terms of what's best for climate, also kind of depends on where you are.
And I was going to add too, I love that you call it a trick question, because I actually think the best one is the one that the farmer's willing to try and work with within their management system. You know, whatever one they can make work is a move in the right direction. So yeah, well, I think that covers the chat questions. I think we maybe move to our second breakout conversations. Questions were there, but again, your breakout room moderators, that's okay. We have those too. And I think we're just really interested in learning a little bit more about reactions to this tool, how you might use it, any questions you have. I'm kind of curious too, is this reasonable? Like, what would it take for Illinois to actually achieve this? So if our breakout rooms are ready, Catherine, we can launch those, and yeah, we'll continue.
If we have everyone coming back, all right. And is Jean here? There's Jean. Okay. Hey. So I think, Jean, do you suggest we go right into the demonstration and do Q&A at the end?
I think so, yeah. Yeah. Okay. Maybe about less than 10 minutes. We can run through the demo in about 10 minutes or less, yeah?
Yeah. Yeah, so.
And Carla, we'll get the link to those case studies in the chat again, as well as we can repost the link to the Illinois 2-pager. Oh, I didn't realize the chat reset every time we come back. Oh, learn something new every time. Thanks, Rachel.
Right. So, you're seeing my, are you seeing my chats over here too?
Yeah, we see that.
Okay, so let me stop sharing and I'll just share the browser window. Yeah. Okay. So the link to the Carpe tool will bring you to this page, which I was having trouble with yesterday. So it's an AFT page that normally over here on the left will say access the Carpe tool. And it will take you to this link that I will also put in the chat since that page isn't quite working. There's that. And so you come to this page and sort of an introduction. There is a user guide that you can always access there. And what I do is most of the action, most of your clicking is going to happen over here in the left. So you go to run Carpe and then it drops down. And so you can go first to the filter data. So you can actually pick different ag census years. Right now it's just 2012 and 2017. When we get a new census, that'll be updated. And then here's where you can go to location. So you can do geographic region. And that means you have these different regions and each of these drop down into all of their states. And you can click over here. I always just leave it at county level, but you can just do state or region. It all gets pooled to state anyway. Another option is to do by farm resource region, if you want to do kind of a regional thing. I'm usually working at the geographic region, and we're here in Illinois. So that question we had earlier, does this work for other states? This is where you can select other states, and you can do multiple ones together. So we could also look at those results. So once you've selected those, you go to management information over here, and you can choose from cropland management practices to cropland conversion. So that's like, say you're transitioning some land into CRP. What are those practices? How is that going to change your carbon emissions? And then also we have grazing land management options and grazing lands conversion. Kind of similarly, both of those conversion usually means adding more woody species. Being Illinois, and there's a lot of croplands. Let's look at that one. Although I did hear we do have a dairy person on the call, so that's great too. So there's some stuff for you there too with grazing lands management. So let's look at cropland management. I usually just leave it as it is here, but you can, so you get total cropland acres. And that's what allows you to see results from the survey, because the ag census survey, it tells you how many acres are cover cropped in a county, but it doesn't tell you those acres by crop. So if I filter out just to look at specific commodity, like if I just want to look at corn for grain, I'm unable to see the current adoption of cover crops because we don't know that by crop. We just know it by county. So I'm going to go back up here and just say total cropland acres. And then the cool part, the fun part is you go to practice. So if I just ran it right now and went to visualize data, I'd see current results, what we know from the census. And that's cool, you can map that stuff out. But if you click yes, you'd like to evaluate a conservation practice, then you have all these cool options for picking a practice. And so there's cover crops, conservation crop rotation, mulching, all this good stuff here, and they're different in the grazing system, right? So would anyone like to come off mute and shout out which practice they'd like me to choose here?
Cover crop.
Cover crops, okay. What's that, Tori? Okay, great. And so with cover crops, there's all these different choices that you then make. So you need to say, all right, we know the 2017 adoption rate, but the carbon benefit differs by how many of those acres were legume and how many were non-legume cover crops. So you have to make some assumptions. So an assumption, you can see it's already set at 10% legumes because that's kind of uncommon, and mostly non-legumes because that's what's most common. So that's going to give us our carbon benefit from current adoption. If you had some knowledge that you were like half of the acres are doing legumes, then you would just drag this knob up here, and then you see the one on the other side adjust. But I'm going to leave it at like 10%, 11, 10, 9. Okay. And then we're going to run also a scenario. So I'm like, yeah, we're only at 3% acres right now, but I think in the future it's going to be X%. And I want to know what the carbon benefit of that will be. So who wants to shout out or go ahead and shout out a percentage you want me to put in here?
50%.
50%, love it. Okay, 50%. And so this is already kind of nudging us to say maybe more of those will be legumes and less non-legumes to kind of get at that. But you know what? I actually just want to compare apples to apples. And so let's say, just so I know the difference between the two scenarios is acres. So you can go to estimated cost. You can also skip this part. But that's going to tell you these are the national averages for the costs for adding a legume and a non-legume. You can also just click right in there, I believe. Yeah, and say, nope, in my county, it's actually $35, or something, and it'll run that. But I'm just gonna kind of clear that out because I'm not too worried about that right now. And then the fun part, and notice over here, it's keeping track of all of my selected values, right, that we've chosen. Then you go to visualize data. And the map is really fun. So we did those 3 states. And if we zoom in, it'll actually tell me what the county is. And the map we've chosen right now, you can also change the color scheme. I like to use this one. And then there's available maps. So right now it's telling me for the scenario we chose. So for that 50% adoption, what's the tons of CO2 equivalents per year? And so it's telling me when I hover over different counties, the county name and the tons of CO2 equivalents per year. And you can export these results. It's also giving you kind of a table of things. You can look at percent acres for your scenario. And I think, there you go. So there's the legend down there too. It's also helpful if you're like writing a report or you want to make your own graphs or something, to go to the table option. And it's sort of a drop down system as well. So you see for that region, those 3 states we chose, you drop that down. We've got our 3 states. You've got the totals by state, and make the window a little smaller here so we can scroll. I just need to go way down here. And so you can scroll over, and then there's all these different columns of information. And it also gives you the information by county. You're not really able to just run this whole tool just for a county. You're gonna have to run it for the state. But that's the general gist. And since we're running out of time, I want to go ahead and stop so we can get questions. And I see that Ellen has her hand up. So why don't you go ahead and ask your question?
Thanks, Bonnie. Great presentation. An interpretation of the table or the map, if you were to state in one sentence the results, would you be saying that this is showing the result of how much CO2 emissions you could capture between 2017 current rates and then just the new amount? So it's like 50%, because the scenario is 50%. So it's saying this much CO2 is captured by increasing cover crop on 50% more land.
Good question. And so what the new scenario is saying, it's not 50% more. So it's not taking, we have currently 3% and we're going to add 1.5%. It's saying 50% of those states' acres. And so the results give you what's currently happening. So I'm trying to show, so over here where it says 2017 in terms of the tons of CO2. And then this is a great question. And over here it says scenario tons of CO2.
And that's captured from the practices.
Right. So it's not the whole system. It's just what that change in practice does. And this is what is 50% adoption. And so if you want to know what the difference is, you would subtract those two things.
Got it.
Yeah. Helen.
Yeah, my question is the 50% adoption like applied to each county, and then that's how the numbers are calculated?
That's a good question. So if we go back, Actually, I think it gives us percent of acres, new percent. So as you can see, and is that too small? Do I need to zoom in to the table? Wrong way.
I think we can see it. Oh, that's smaller now.
There we go. Yeah, I went the wrong direction.
Yep.
So this is giving you over at the far end of the table, the percent of acres by county. And then you can see that the new adoption is getting us to, then the far right, this is the scenario percent. So it gets the state to 50%. And then this is the new adoption. So this is the new percent of acres here in the middle. I'm not exactly sure what that math is there.
That's okay. Yeah, I'm just curious because, I know that some counties have more, there's more work going on in different counties to get more adoption. So I'm just kind of curious.
Yeah. Other questions or things happening in the chat that oh, we got suggestions on which legumes grow in Illinois. That's great. Have you heard of covercress?
We have heard of, I've heard of covercress. It's a brassica-based crop, and they're trying to develop it so it can be kind of a winter cash crop. It would both serve as a cover on the soil, something that's growing in between the corn and soybean rotation, but could also be potentially harvested for the seed as high oil content. So that's a potential. I might, so for folks who are on the call who are really interested in cover crops, I will do a shameless plug for our Illinois Cover Crop On-Farm Network, which is a network of people who meet monthly and discuss different topics around cover crops. And I think Helen might be able to drop the link in the chat to some more information about that, and you can join that. We have talked about different clovers. We've talked about covercress. We've talked about termination strategies through those calls. And we also will be launching a summer series that's looking at mixes of different cover crops. So check that out. I think, and then also again, the Midwest Cover Crop Council is a phenomenal resource for all things learning about cover crops, trying to filter your cover crops based on your goals. It tweaks it based on where you're located. So it even kind of recommends different planting windows if you're in Northern Illinois versus Southern Illinois. It's a really great tool. So in addition, of course, to CARP-A and the soil health economic case studies, et cetera. So I know we are short of time. I think there's one wrap-up slide, and we'll be putting a few more links in the chat here. Bear with us for like 3 more minutes while we do some wrap-up.
Yeah. Go back to Zoom, share the screen. Come through now.
Great. Yep,
okay.
Looks great.
So just to kind of go through what are some of the take-home points from what we did today. So soil health builds soil structure by feeding those underground livestock, and what they do is they improve that structure, which improves function. There are many soil health practices that help farmers both adapt to and mitigate climate change. And scientific research now enables us to build tools like Comet Planner and CARP-A to estimate carbon reductions from soil health practices at the county and state level. And I'll just mention again that Comet Farm tool, which works at the individual farm level. And then Illinois, what we looked at those totals in that scenario, and Illinois agriculture could more than offset its emissions by increasing soil health practice adoption. And you can get all of those juicy details by going to, we're going to put in the chat the report, the page that has the report for this. There's also the CARP-A tool here, although that link wasn't working so great. So also look up in the chat, there's the direct link to CARP-A. And feel free to reach out to Jean or I. We'd love to hear from you. And Jean, do you want to say anything else before we have maybe a few minutes for questions?
Yeah, well, we do have an exit poll that we'd love you to just tell us how we did, so we can launch that. And while you're answering that, it has 3 questions on there, so you might have to scroll down before you find the submit button or answer button. Also, just want to give another acknowledgement to Illinois Stewardship Alliance for putting together this amazing lineup of different events through Soil Health Week. There's a few days left of Soil Health Week, some great events later today and tomorrow, and I think there's even one on Saturday. We can again put the link to their landing page with the whole schedule. And yeah, I just appreciate everybody joining us this morning. Happy to, and thank you to Bonnie for sharing this information, of course, and all of the support crew who is doing the breakout sessions and all of you. I'm happy to we can stay on through the bottom of the hour. If there are any questions, feel free to linger and pose them. Otherwise, the last thing is we have recorded this and we will be following up and figuring out how to get a recording and any additional resources to you in the next week or so. Thank you again. We'll stay on if